Okay, so we're back. We've got a proper replacement pellet tray in there now. The motor's going the right way, I think. Still a bit dodgy on the wiring. And I think we're ready to pour a few pellets in and just totally guess at what speed it should extrude at. No idea. I'm just going to stick with the default settings for the BMG that's down there somewhere, and we'll tune it from there, I guess. Right, so we'll get some pellets and we'll pour some in just through the hopper for now. So it definitely takes a fair bit longer to warm up with the cooling fan on. That's what, nearly 4 minutes, and the curve's massively plateauing out. Could probably do with maybe 2 heater cartridges put in, if that's squeezable. Or I could always turn down the pulse width modulation on the cooling duct fan. But you can see it's creeping up, but it's taking its time. I think what I might do, I'm going to alter the pulse width on that fan. So to do that, if you go into system, look in your config, under the fans, there's the various fans, but I think on this printer I can't remember whether it's wired straight into just a 24 volts. I'd have to check, but you can alter these, and you can alter the effectively the maximum speed of it. I'll show you on the another day. I think it's going to be easier. It's a bit tricky to do it right now. We'll see how this is doing. So it's slowing down. It's getting there. I think I'll just move the fan for a minute and see what happens. So yeah, there you go. So the cooling fan is having a very positive effect on the cooling of the heat break. You can see where I disconnected it, and suddenly it's gone whoosh like that. So we'll put some pellets in. I've got some here, and we'll try driving it and see what happens. Put these into the hopper. There we go. Alright, and we'll start extruding. Okay, so you can see that it's turning. I've absolutely no idea whether this is going to work. Obviously going to be a fair bit before it actually squeezes anything out. It's not exactly going particularly fast either. But the pellets are seeming to be dropping in the screw. We're going to go at maybe another. Do 5. 1, 2, 3, 4, 5. When you think about it, it's barely doing a rotation. But it must be getting close now, I would have thought. This is nearly 4 minutes, and the curve's massively plateauing out. Could probably do with maybe 2. I mean, I think we'll give it a bit of a shove now. Go a bit faster. I'll go at 3 times the speed. The only thing I think is possibly I'm actually sending the screw the wrong way around, but let's see. Let's go in a fair bit faster. there's the various fans. But maybe I am going the wrong way. I'll try it the other way. I'll do minus a few hundred. The quickest way of doing that's just to retract. I'll do 5 the other way. Maybe that's where I'm going wrong. Possibly been going the wrong way. So let's do a few more. Do 10. 1, 2, 3, 4, 5, 6, 7. 7. Let me do. There we go. Something's happening. It's got hot. Oh. Okay. Yep, there we go. That's way, way hotter than it should be by the looks of it. But I is feeding it. So I suspect our temperatures are off with my temperature gun. Because that's way hotter than it should be. I'm going to do another calibration of the hot end. Because it's, the thermistor value was miles out. I should have remembered about the reflectivity of metals, but hey ho. So it'll be interesting to see. It should get up to speed a lot quicker now, up to temperature, and it'll cool down quicker as well. So I've changed the fans, so we've now also named them as well. So I've got this first on the, rather than be connected to 24 volt always on fans, I've connected it to the pulse width modulated fans on the board. So there's 3 of those. The first one I've now called it with this C parameter, the hot end fan, and I've set it to be thermostatically controlled and come on when the temperature gets to 60 degrees. And the part cooling fan, make it easier, renamed it as part cooling, and obviously that doesn't have thermostatic control. Actually, I'm going to turn that. Not sure. I want that to run at 50% speed, so that's about 125. But I'm not sure how that'll work with the thermostatic control, so I think we'll just bin that off. So that'll run a fan called hot end fan at 125 out of 255, so that's about 50%. And there's the part cooling fan. And just get rid of that. So if I save that and reboot. There we go. And go on to console. So everything's at 26 degrees. If I go on to status, so that they see it's picked the names up. Hot end fan set to 50%, part cooling fan 0. So let's do a heater calc now, heater calibration with the fan reduced a little. So I'm expecting that to heat up quite nicely now. So let's see what happens. This massive spike in temperature is when I was moving the things around and changing the connections. The thermistor came loose, so when they go open loop, yeah, they go up to massive temperature. So yeah, so the hot end's going up nice and quick now. So I expect that to get to 240 quite nicely. So we'll come back when it's achieved the target temperature. So yeah, let's see, much nicer gradient there, whereas before it was a huge curve going out here. 1, the thermistor was miles out, and 2, the cooling fan for the hot end was too powerful. So yeah, we should get some nice figures off that. I'll come back when it's finished. Yeah, there we go. So that looks a reasonably good balance. I might set the cooling fan to 30, just a little bit higher, rather than 50%. But it rapidly heated up in 3 and a bit minutes, maybe nearly 4, to 240, and then it's cooling down quite quickly as well. So yeah, that's sort of typical of what you get on your FDM printers now. So I suspect when this gets below 100, it'll say tuning complete. Right, so I've created my own custom mount based off some of the ones from Greenboy 3D. This is going to go on the Modix. I think I'm just going to go straight for that really, rather than try printing something on the small printer. What it's got on the back is the way mine's aligned on my Modix at the moment, is it's an extruder motor at 90 degrees into a dual BMG, so this should mount straight on there. It's almost the same length as the previous setup, with a direct drive 2.85mm feed. So as you can see on here, it's going to effectively mount where this motor is at the moment, with the 4 holes, and the overall length is pretty similar to this system here. Not sure yet whether I'm going to keep the roof. Might do, but I'm going to effectively run a hose from here, either through a hole drilled in here, or I'm not sure. I was going to use a Hoover cable, like from a Dyson or something, for the Hoover attachment. It's quite stretchy, but I still think there's not a lot of travel, especially if it's travelling to the far edges, so I might end up maybe taking this off completely, the roof. I'm not sure yet. Obviously hopper feed from above it. But yeah, it's going to go on there. So we're back to this. I've used some clumsy mounts there, but I've actually got 3.5mm, or there's actually 3mm brass threaded inserts into here. There's also 3mm brass threaded inserts into there. I'm not too bothered at the moment about being able to empty this with pellets easily. I might modify this so that you can. So at the moment I've just combined the tray and what would look like a hopper into just a blank for the Modix. So we'll see. Right, so we'll extrude some plastic with this now that the settings are pretty much correct. I'm just going to have to pour them into there. We'll check the settings now for the Esteps and sort of a bead of plastic that's consistent. And then I think it's mount on the Modix once it's stopped doing some of its jobs. So I thought I'd recorded a video of the extrusion and playing around with the settings, but for whatever reason I hadn't. But the sort of correct setting is around 1200 to get a visual bead of plastic that looks okay from the nozzle that's on there. But that'll need fine tuning. Actually trying to print, like a brim or something, or just a skirt for a part, and just use that only, or just print just a single line on the bed to try and tune it to be the correct line width that the slicer's demanding. But 1200 seems to give a decent bead to start with, and I guess you can play around from there, a few hundred either way to get the flow about right. So anyway, we'll go put the pellets in and you can see that it gives you a nice bead. Okay, so let's pour these pellets in. Let's use this funnel for now. do. Plenty in there. And we'll go and see if we can extrude and get something coming out. Okay, so we've set it to extrude. Hopefully should start seeing something coming out in a minute. Pellets are definitely going down. It's quite, if you look at the screw, there's quite a long filament path to fill. You fill up all these voids all the way down effectively. It's quite a lot. So it does take a bit to prime it. It should get something coming out soon. Come back when it starts doing it. Well, you can start to hear it bubbling and crickling. I expect something to start coming out any minute. And here we go. We'll just send a few more extrude commands. It took a fair bit of priming. There we go. This temperature was a little high as well. I've turned it down to 205. It was at 220. So there's a pretty consistent bead coming out now. In the top though, but it's starting to go down. It's gone down a lot actually. It's a lot. Yeah. Extruding at 5 millisecond. I was asking it to feed sort of 100 mil. So I'm going to do 15 millisecond now and see if that'll feed. Not quite sure what flow that's going to equate to. But yeah, we'll see if it can feed that. Wow, that's quite a lot of plastic. That's a 2 mil bead coming out at, well, who knows what 15 millisecond. I don't really know what the flow is. So a lot. We'll try it at what it thinks is 30 millisecond. Again, not sure what these settings equate to right now until we've dialed it in and actually tested it. We're not trying to extrude a fixed line width, but let's try. Possibly expect the stepper motor to stall at this point, but we'll see. It is, yeah, there we go, starting to struggle. But it had a go at doing it. It certainly had a go. Don't think we've run out of pellets. Nope. We'll just extrude a little bit more at normal speeds, and there we go, back at 5 millisecond. Extruding. Nice bead of plastic. So yes, it's a 2mm nozzle with whatever the Esteps are, and it thinks it's extruding 5 millisecond based on the various settings. Who knows what they really equate to right now, 'cause it's all a bit different with the pellet extruder, but that looks like a reasonable sort of flow rate. Got a nice, I'm just going to pinch that away. It's a nice steady bead of, this is PLA that we're using that came with the kit. So it's somewhere near working. Interestingly as well, I haven't got, I've got the cooling fan connected, but I haven't got the duct going down to here, so it does still feed quite nicely. But I'm sure you do need something up there, because it's going to, eventually this is going to heat soak and the heat's going to travel up here and you're going to end up with a problem. Although, you know, flowing a lot of plastic will keep, you know, there'll be a balance point where you're flowing enough plastic for enough heat to go into the plastic to not heat creep into the rest of the surrounding structure. But I'm pretty sure you'll need a cooling fan for the heat break area, and you definitely need one obviously for part cooling. So I'd say this design is ready now, and it's ready to go onto the Modix. Okay, so that 100mm commanded at 5mm a second has resulted in this coming out, which is around, we'll call it 71mm, and the cross section, or diameter, is about 2.75 out of a 2 nozzle, so it's definitely flowing too much. If we calculate the volume of that against, it's going to be a bit approximate because it does taper a little bit, but yeah, there's a bit of a kink, but we'll start getting it closer to dialing it in. So we'll work out the volume of that. Just going to do a volume of a cylinder on it, and also the volume of what was commanded, assuming a 1.75mm filament, and then work out how far out we are. So simply, the radius, on average it's about 2.8 mil, so we've gone 2.8 diameter, so radius is half of that, 1.4 mil, and the height of it is about 71 mil. That gives you 437 millimeters cubed. And then what was commanded, we'll say it's 1.75 mil filament, so 0.875, and it was 100 mil. Which is 240.53. So there we go. So 437 is what came out, and commanded 240. So it's about double. So I'm going to halve the Esteps, I think, and we'll see what happens next. Okay, so that was what the Esteps were set to, 1200. So we'll go for half of that now. I'll go for 600. Save that. I'll have to reset the main board. And then turn the heater back on. 205. Right. And we'll try extruding 100 at 5 now again, and see how that looks. Well, I've done 2 lots of it there, so we should have a longish string that should be around 2 mil wide. Yep, so there it is, coming out. Get rid of that. So it's definitely looking thinner. Just let it cool off and measure it. So visually you can see this this first attempt is quite a bit thicker than this one, so I'll put it in the verniers. Maybe let's see what we're at. That's pretty close. So it's 2mm nozzle and it's 2.1 extrusion. Let's just try it a bit further down. 2.2. That's not the best at the bottom there. Let's carry on there. 2.06. 2.19. So it's pretty close, that. I think these steps are probably about right now. And the final sort of tweaks can be done with material flow rates. I was just going to try feeding 100mm of plastic at 30mm a second. I reckon it should cope with that. I'm going to do 2. Yeah. Did it, no problem. So basically now that's the pellet extruded, calibrated, based on an input of 1.75mm equivalent diameter on a plastic reel. So all these figures now and the steps effectively work for 1.75mm filament. So effectively you can set your slicer up now, tell it it's using 1.75mm filament for all the flow calculations and everything, but you're actually using a pellet extruder tuned to be against, you know, tuned for that setting of 1.75mm, but it'll allow you to flow quite a lot of plastic. Okay, and a quick final calc on flow rates. So yeah, 100mm at 1.75 gives 240mm cubed. The filament was at 30mm a second, so that gives you 72mm cubed per second. There's a couple of simple flow rate 3D calcs on the web. One's at All 3D Printing. I'll put the link in the description. And that would sort of give you an example with a 2mm nozzle, 0.6 layer height, sort of max printing speed of 60mm a second, which isn't too shabby. So we'll look to push that a bit once it's installed on the Modix. So yeah, so thanks for watching. I know it's sort of a bit of a mix of informative and tech detail and instructional, this video, but hopefully find it interesting and useful, and we'll get to, like I say, pushing this on the Modix and seeing what it can really do in the next few videos. Thanks, bye for now.